Hi guys, I'm Tungsten. So this is the part 3 for the Rapidstrike mod, whereby I talk about the circuit. So as you can see, it's quite a mess. So we'll take things part by part to talk about it. Oh yeah, by the way, I'm not too sure whether anyone is interested in me talking about a little bit on the programming side of this mod. If you are interested, just leave me a comment, so at least I know. And if there's enough interest, I'll probably do a part 4 whereby I talk about the programming of the blaster itself. So yeah, let's move on to the circuit. So let me just put it part by part. So by the way, the diagram will be available under my GitHub account. I will put it under the description link itself. And normally I'll just put an overall circuit diagram, and then I will also save it as break it down into small parts. So if you are like wiring up the OLED display, you can just look at the OLED diagram itself. But let's go ahead and let's take a look at the circuit itself. So first thing first, let's look at the battery over here. Okay, so as you can see, basically this is just a LiPo battery, and then we have a female connection over here. So normally the one that you're supplying the power is basically a female connector, so there's no chance of less chance of you short circuiting it. Alright, so next, okay, basically you can prepare how do you want to supply the power to various components. So in our case, we know that we're going to supply power to the flywheel. That's one, and then this is one for the flywheel, and then one will be for the pusher itself, and then the last one is basically we're gonna read off the voltage of the battery to gauge the power left. So again, as you can see, I connect it to a male connector, but when it's to the other side, okay, if I want to make it such that it's modular and I can remove various portions, then I'm going to use a female connector, because this is the one now is going to supply the power. So it's a good idea not to use the male connector, so that you don't have something protruding out and then you accidentally short circuit it. So normally that's what I do. Okay, if you are supplying power, female connector. If you are receiving it, then you use the male one. Alright, so now I have three, more or less 3 connectors, whereby I can connect to various portions of it. So let's just look at the flywheel setup itself. So this is the flywheel. Okay, so we have our typical motor over here, and then of course it's going to receive some power. So hence I'm going to use a male connector, right? So to basically activate the flywheel, we're going to make use of the Arduino itself. So what I'm going to do is basically I'm going to use a MOSFET, okay, and then control the switch on the MOSFET through the Arduino itself. So this is basically the wiring. So over here, let's take a closer look. Alright, so if we take a closer look at the basically the setup itself, so this is a typical MOSFET setup. Just a few things. But by the way, if you want to look at how I wire up all the MOSFET stuff, I do have a video on doing a MOSFET for a normal setup. So everything is the same, except that for the gate itself, instead of supplying it through the activating through the a switch, a micro switch, this now links to the Arduino itself. So as you can see, these are some of the components I use. 10k ohm, and then there's 100 ohm over here. The reason I put it here is not to protect the MOSFET, rather it's just to protect your Arduino board itself. So if anything goes wrong, you know that it's not going to have a high current going through the gate itself, and then you burn out one of your Arduino's pin itself, something like that. Okay, so basically again from the battery we have the power over here. So to connect and do a connector over here, so that this eventually will this actually goes all the way, okay, and then to your flywheel itself. Then of course the negative will go back, okay, over here. So if the MOSFET is active, and then it will flow from the drain to the source, and then the circuit will be completed. So that's how the MOSFET works. Okay, so over here, so this is the diode. Okay, so this is the flyback diode. Okay, so the when the flywheel is not running, it's still spinning, so it's gonna produce some residue power, so that you want to channel it back, and then let it just wind down. Okay, so you can connect it across here if you want to. Sometimes I do that. Okay, so if you do that, then the advantage is, of course, this entire setup itself, it is a separated unit. You can actually remove it as a unit itself. Okay, sometimes I will move this diode all the way closest to the source of the residual power over here near the flywheel. So that's what I did for this mod actually. So let me just bring back. Okay. Alright, so by the way, the gate itself will connect to just the pin over here. So you can see it's connected to D3. By the way, if you look at the programming itself, the first portion of it is all the decoration of the where the pin is connected to. So it should be quite straightforward. Now back to this diode over here. So for the mod itself, what I did was I actually connect it all the way, okay, over here, just across the terminal of the 2 motor itself. So it's actually very close to the source itself that is going to produce the leftover power that you want to run down. Yeah, so you can do that. You can move all the diode all the way here. So, and in fact, to me, it's actually easier to do the soldering as well. And by the way, these 2 pieces of green thing that you see over here, basically they are just capacitor plate, whereby attached to the motor to reduce the electronical noise. So if you are dealing with microprocessor things as such, okay, so I believe it's a good idea to remove all the electrical noise, I mean, as much as you can. And now if you don't have this kind of plate, basically you can buy your own capacitor, whereby you'll see later on when I show the pusher mechanism how it works. Okay, so basically this is the first part. I'll say that if you can work out this portion, the rest is very easy. So when coming into the mod itself, one of my major objective is to reduce the complexity as much as I can. So meaning if I can isolate things as a simple subunit, I'll do that, and try not to complicate things by adding 2 units together or something like that. Yeah. So the next I'll say the next 2 complex portion of the circuit is basically the I'll just say the ESC is probably the most connection that you need to have. So let's take a look at that. So okay, okay, so maybe I'll just off the MOSFET portion. Alright, so let's take a look at the ESC itself. So you have the pusher, right? So this is the Rapidstrike pusher. Right now, then of course it's going to receive some power. So this is going to be a male connector. Then this is the ESC itself. Okay, you have 4 wires over here. A pair of it is going to receive power from the battery itself. So again, the connector goes here. So you're going to receive power, right? So once you receive power, you're going to supply it. So it's going to channel it out to the pusher mechanism itself, the pusher motor. Alright, so how do I control it? Is of course through the these 3 wires over here. There's one that's white, there's one that's red, and there's a ground, and then there's another 2 wire with a switch actually, but I cut it off basically to replace it with my own on-off switch. Okay, so again, the reason why okay, by the way, there is some jumper that you need to set over here to have forward braking, and then to indicate that you are using a LiPo battery. So that's about it. So again, why do I choose as ESC? Because I believe that it actually make the circuit easier to implement. In a way, you have less thing to solder, and it's pretty straightforward. Receive power, supply power, control the ESC through Arduino. Okay, so over here you can, this is pin number 9, and then of course there's an on-off switch. Why do I need an on-off switch? So basically I'm also using the ESC, the onboard BEC, to basically supply a 5 volt to the Arduino to power it up. So over here, in fact, the red one, if you can see, okay, I'm going to connect it to the Arduino 5 volt. So this actually powers up the Arduino, and of course this is going to go to the ground. Okay, so with the on-off switch, when you switch it on, then it actually powers out the Arduino, and then of course you will basically check for the ESC, and then do all the okay, and then everything will be power up, in a way. Yep. Okay, so so this is the reason itself. Again, of course, you can see that there's capacitor and a heat sink over here at the ESC, so I guess it's a bonus for this ESC itself. And then the sort of like the space required for this guy over here is actually not very big, so it's pretty good in my opinion, and it actually reduces the complexity itself. Alright, so if you put back the MOSFET itself, then the circuit becomes slightly more complex, but it's still manageable in my opinion. Alright, so next, let me just off again all these things. Okay, left with the battery. Alright, so the next thing, okay, so it's basically just a duct counter that's sitting on top of the pusher mechanism. So again, you can see that it's only 2 wires. One you connect it to the Arduino pin itself, then the other one I connect to the Arduino ground. So I didn't draw the sort of the Arduino ground to the board, but I indicate it as Arduino ground. So basically this is to be connected to the Arduino ground itself. Okay, so most of the case over here, if we have a switch, normally this is the setup. It's just 2 wire, one to the ground, one to the signal. There's no pull up resistor or pull down resistor, because I'm actually using the onboard pull up resistor from the Arduino board itself. So this will again reduce the wiring required. Alright, so that's the duct count itself. So if I were to off it, okay, so the next one is basically the Hall sensor. Okay, so for the Hall sensor, I'm just going to use it as an on and off thing. So I have 2 of them. Of course, one of my subscribers told me that, of course, the Hall sensor, you can also gauge the polarity. Okay, some of the Hall sensor, you have that ability. So you can gauge the strength, and then connect it to analog read or something like that. Then you can gauge the strength, and then you can do even more detection. But for myself, I'm just going to treat it as on and off. So if you so I have 2 Hall sensor. Okay, so it's the A3144. Alright, a simple Hall sensor over here. So each of them will have 3 pins. One you connect to a 5 volt, one connect to the ground. So you can see this one, for the Hall sensor, you realize that one surface is flat, the other one is have a little bit of an edge. So the edge one is supposed to face the magnet in this case. So this is I've turned it upside down because that's how I wire it for my application. So just read the sort of the data sheet to find out the actual pin, which one is the connect to the 5 volt, and which one connect to the ground, and which one to the signal pin. So if I'm not wrong, it's in this orientation. So again, I have connect both to 5 volt, so you can connect it together, and then to the 5 volt, and then 2 to the ground. So and then the other 2 will be to the pin, this to the pin, this to the pin itself. So again, so if you have sort of like 2 Arduino itself, again, you don't see any resistor. I pull out resistor that I connect to the pin itself, because I'm using the internal pull up. Right, so by default, if nothing is no magnet, or it's actually a 1 1, a signal 1 1, then of course if there's a magnet, you go to sort of like 0 1, and then 1 0, and then of course you can have 2 magnet, then it will be 0 0. So this is a very nice binary pattern basically. So you can just use a formula to calculate. This can be a 3, this 1, 2 2, and then 0 of course is 0 1 2 3 itself, and then you can decide what to do with it once you detect the pattern from the Hall sensor. So that's how I use it. So it's pretty simple, straightforward. Okay, so only 2 pins to the D7 and D7 and 8. Yes. So again, you can refer to the programming itself, and you get the idea. So like what I say, I try very hard to sort of like think of the what I can do to reduce the complexity. So as you can see, no, this is slightly more complex, but not really, right? You just 4 wire, one to the pin, and then the other one to the 5V, and then to the ground. So you can see, if you can wire up this portion, I'll say that you're almost there. The rest is really pretty straightforward. Okay, let's look at the rest. Okay, so the trigger, yep, just a micro switch with 2 wires, one to the ground, one to the Arduino board itself. Okay, that will be D6, and then the ref itself, again, one to the board, one to the ground, one to the pin, one to the ground, sorry, and then the mag relays. Okay, one to the board itself, and then one to the ground. Okay, so that is 3 of them. So the next one is basically the selector. So the selector is basically is like a 2 switch in one kind of situation. So I have a ground, and then I have like in fact I have 3 pins, but I only need to have 2 because I only need to detect is this on, or both are off. Then I know which position of the switch is really activated. So basically I only require 2 pin in this case. Yeah, I have other switch whereby I know you can use 4, sort of like 4 pin, and you can have 16. Is it 16? I can't remember. I think 16 kind of combination, because it's like a binary kind of situation. But I only need something like this, and it's more comfortable. So this switch, so I use it. So I only need 2 pins and 1 to the ground. Alright, so for safety is the same. It will be 1 to the ground. I don't have the ground symbol over here, and then 1 to the pin. Okay, so next is the rotary encoder. Okay, so for this case, okay, let me just blow it up a little bit. Okay, so for this rotary encoder, I choose to buy one that is already soldered into a sort of a small circuit over here. Why? Because it have all the capacitor and resistor as part of the circuit itself. Because for the rotary encoder, you really want the signal to be quite clean, so that you don't force detect any of the rotation, right? So on top of that, this guy also have a push function. So itself is like a button itself, whereby you can push on it. Alright, so this is again, they have 1 to the 5V, 1 to the ground, and then you have 3 more wires to connect to the Arduino board. One of them is basically for the push button, and one is for a signal from the rotary encoder, and a B signal. Why do you need 2? So that you can detect clockwise or anti-clockwise situation over here. Right, so you probably can find other rotary encoder that is in this sort of setup, so that you can use them as well. So if it's not the exact one that you see here, if that you got. So if you want to get a rotary encoder, get something that already have the capacitor and resistor solder on it, and so that you don't need to do that to clean up the signal. And of course, you can get one that act as a push button as well. Yep. There. Okay. Alright, so I think the last one will be the OLED display. Okay, so the OLED display I'm using is 4 wires. Okay, one to the this, you have to take note for this guy that I'm using. Check what is the voltage that it requires. So for mine is 3.3. So basically I connect it to the 3.3 for the Arduino board, and then 1 to the ground, and then two of them is basically to the reserve pin of Arduino for the A4 and A5. Okay, so this is reserve. Yeah, so let me see. Oh yes, so I I talk about the pusher. Now, if you want to clean the signal and if you don't have the capacitor plate, so you can buy this kind of capacitor itself, and then you can solder it to the terminal and then to the case of the motor itself. I think for my previous video, I also linked to the article whereby they talk about how to clean the electronic signal for the this sort of application. Alright, so there we have it. We have the signal. So let's just do a quick recap. We have an Arduino, then we have the battery pack. Okay, you need. Oh, sorry, I think I forgot one portion. So let's do it over here. So we have the battery, and then we have one to the flywheel, one to the pusher. Then what's the last one? The last one is basically to the voltage, right? Voltage sort of detection. So again, connect it. Okay, pass it to the voltage. Sort of a sensor board, not really a sensor board, but something for you to read off the signal, and then to the ASICs, and then you can read off the signal. Right, so we have that. Then we have the flywheel, right, as a module, and then we can connect to the MOSFET. Again, the diode of the MOSFET you can either apply across here, or you can apply across here. Choose one, and I believe this one is actually easier to implement, right? And then we have the pusher, then we have the pusher ESC, okay, which have an on-off switch. Okay, this will power off your Arduino. Then we have the duck count, hall sensor, trigger, ref. Okay, I forgot about it. Did I forget about this? Okay, anyway, the mag release. Okay, then the selector switch. Oh, safety. Okay, safety itself, rotary encoder, and then the OLED display itself. So now you have the complete circuit for the build. So if you do not need any of the function, so for example you don't need the detection of the capacity, basically you can just not connect this portion to the Hall effect, and the program you can leave it as it is. You'll just not do anything. Okay, so you can actually omit this portion. Right, so if you don't sort of in a way, if you want to reprogram it such that you don't need a selector, you can simply do that. So yeah, or even the rotary encoder, if you don't need to use it, you can just take it out and leave the program as it is. So yeah, so there you have it. So this is the circuit for the Rapidstrike mod that I did. Hope you enjoyed the walkthrough. So again, if anyone is interested in knowing, having me talk a little bit on the programming itself, leave a comment, leave a like to the video or something like that. Okay, let me know, and I can spend some time to prepare for it. So I'm Tungsten. Thanks for watching.